Okay, so welcome back to this next video in which we are discussing the digestion and absorption of fats. Okay, right, so we're just in the process of discussing the different sorts of lipid molecules that you will have in the diet. So we've discussed triacylglycerols or triglycerides, and we've discussed phosphoglycerolipids. I now want to discuss cholesterol and cholesterol esters. Okay, right, so let's start with the structure of cholesterol, and then we'll talk about the structure of cholesterol esters. So basically, cholesterol is a sterol, and to understand what a sterol is, we need to understand what a steroid is. So we'll start off with what a steroid is. Okay, so steroids basically have a structure which contains 4 carbon rings. Okay, so this is going to be the steroid structure, and this surprises people when they see it for the first time, because most people think that the definition of a steroid would be biological. Most people think that, steroids are all hormonal molecules, and that therefore their definition is that they will affect the body in a certain way. However, the definition of a steroid is actually chemical, okay, so it's based on a chemical structure definition. So, basically they have this structure where they have these 4 carbon rings. So we have 3 6-membered carbon rings, 1, 2, 3, and then 1 5-membered carbon ring up here, which is usually drawn like this, so that it makes a nice sort of straight pentagon like that. Okay, right, so that's the structure that you have to have within you in order to be categorized as a steroid. Now, the structure of steroids and sterols are usually drawn skeletally, because, as you can see, when we draw the skeletal formula for a steroid, it's a very, very simple drawing that we get. Whereas if we were to actually draw the molecular formula for this, it would be a nightmare. Now, basically, in skeletal formula, you don't show carbons. They're implicitly shown as these sort of meeting points, or these corners, okay? And you also don't show hydrogens coming off carbons. And basically, in the core steroid structure, all you have is carbons and then hydrogens coming off carbons, which means that the structure becomes extremely simple, like so. Okay, so for instance, if we look at this carbon here, you've only got 2 bonds, so the other 2 missing bonds are implicitly assumed to be coming from hydrogen atoms which are bound off that carbon atom. Okay, right, so that's what a steroid is. Now, to turn a steroid into a sterol, all you need to do is stick an alcohol group off here, like so. So that molecule then now is a sterol. Now let's specifically create cholesterol. So what do we need to do in order to specifically create cholesterol? Well, basically, cholesterol has a double bond here, okay, like so. Then it has a methyl group here and another methyl group there, okay, right. In addition, you then also have a group coming off this carbon up here, which looks like so. So you have a 7-carbon structure here, so 1, 2, 3, 4, 5, 6, 7, like so, and then you have a methyl group coming off like that, okay, and that gives you the structure of cholesterol. Okay, right, so we can see that it has the alcohol group of all sterols. Okay, and we'll call it there for this video, and we'll continue our discussion in the next video.